Hi, I'd like to show you ISARA Advanced and especially some of the newer features. First, when we log in, we see a dashboard of configurable widgets showing us the overall health, the overall cryptographic posture and scores of our network. If we look at the categories here, I'm going to drill into those a bit more on the Cryptographic Posture tab. One of the newer features here is the TLS Validator, which lets you connect to TLS servers and validate their configuration. So you can either do this on a schedule, or you can probe on command. For instance, if I probe mail.isaracorp.com, our mail server, it's going to start the probe and then report back to us on its configuration. Can have a quick look at those results and see that our mail server is using strong but quantum broken crypto. This is great by today's standards. So if I scroll through, I can see the other data we just determined. I can see that it was listening on port 443. It was using TLS 1.2. I can see all of the cipher suites that it was accepting. I can see all of the key exchange algorithms that it accepted. I can see the bulk encryption. I can see the modes of operation, which have been historically important. I can see the signature which was being used, RSA2K. I can see here as well the hash algorithms used to protect our data and the message authentication codes built on that. I can also see details of our certificate, such as expiry dates, not valid before, and key sizes. Now I'd like to go to the Cryptographic Posture tab. On this tab, we have a filter panel which explains all of the scoring, where we've identified and stratified the risk detected, the crypto primitives, the actual operations that we're reporting on, details of the protocols on the network, and we divided the data into zones so that we can easily classify what we are looking at. We also have 4 main categories: the connections we observed, the devices that we observed, the software we've observed, and the cryptographic assets we've identified. So here in this crypto panel, we have our scoring categories. Some cryptography is unacceptable by today's standards, such as plaintext. If you have a zero trust initiative going on, then you shouldn't be using plaintext DNS, plaintext HTTP anywhere in your organization. However, a lot of people aren't doing that yet, so we also have the ability inside Advanced to ignore by protocols or ignore by IP addresses or ignore by various zones. Other reasons why something might be considered unacceptable is because it's broken, it's weak, it's misused, or we detected a specific security vulnerability. The next thing I want to talk about is the caution category. Here's where we might see non-standard quantum safe cryptography, or cryptography where we couldn't capture the parameters. It might be unknown or custom. A lot of protocols support extending the protocol to add your own variations. Today's asymmetric cryptography is going to generally show up here, in the strong category. Strong quantum broken is where today's RSA keys and ECDSA keys are going to land. When we glance at the inventory for all of the cryptographic primitives, they're going to land here, such as the key exchanges. Here we observe some ECDH, some finite field Diffie-Hellman. We can see the bulk encryption used by our connections. We can see the mode of operation employed by that bulk encryption. We can see the signature algorithms that were protecting those connections. We can see the hash algorithms that were making sure that data hadn't been tampered with or just corrupted in transit. We have the message authentication codes built on top of those hashes, and of course a list of the cipher suites. As for the protocols detected, we can see these here in the protocol section. So in this case, we saw a lot of TLS versions. We saw some plaintext DNS. We also saw something as old as SMB1 in this dataset, and we'll have a look at the reports in a little while to see exactly what the impact of something like SMB1 might be. When we look at the protocol types, we can see that most protocols, most connections we observed, were secure. However, we still did see a large number of plaintext, so insecure, connections in this dataset. If we look at the same thing for devices, we're going to see a very similar set of filter panels. If we're going to look at software, here we're going to see discovered software from our optional CES component, and we'll be able to see information such as where it was installed, which user was running it, which port it was listening on network-wise. So in this on-screen example right now, we can see that Nginx version 1.18.0 Ubuntu 1.7 was installed at user SBIN Nginx. It was observed at this date, and it was running as root doing plain text connections. In the Crypto Assets tab, we have an integration right now with Amazon AWS's KMS, so we can be retrieving key information from KMS. We've also extended CES's functionality to discover certificates. As an example, here is a certificate that was detected on the machine called code. And on code at this path, the following certificate using an RSA2K key was discovered. So it was a CMake test certificate that was discovered on this machine. Looking at some of these other keys, this one here was used for key encrypt and decrypt, RSA4K. So we can see here that it was RSA4K and it came from this Amazon identifier. Our cryptographic posture templates allow users to configure how advanced should behave when they detect specific cryptography. For instance, we believe at ISARA that AES 128 GCM is quantum safe security level 1. These templates here have adopted that as well. However, we give users the flexibility to reconfigure so that any score is available for any item that fits their corporate policies. We do the same thing for protocols. We also give the ability to generate and build compliance profiles. So in here, a compliance profile can be edited, and we might create something such as PCI DSS. We could even spell it right. And we could add that compliance framework, and then we have the ability for every detected algorithm to indicate whether any assets indicating PCI DSS compliance would be a pass or a fail, or whether they should be ignored. Another new feature we have are our reports. So let's take a look at the executive summary report. Here's one generated a little bit earlier today. I'm going to open that. And what I can see here is the generated PDF, which has an overall score, a reflection of some of those widgets that I had on my dashboard, and then an executive summary of what was going wrong in the network data that we were looking at. We also go into a fine detail here explaining why things are bad. For instance, SMB1 was observed in 39 connections, and it's not encrypted, and it's been deprecated for 12 years. So we're recommending that you upgrade to a new version of SMB, the Windows File Sharing Protocol. Another report that I'd like to quickly show you is the zone report. So in this report, what we have is the detail for all of the zones which we decided to report on. So for instance, R&D Lab A scored an overall F. Well, it is a test network. We see those widgets again. We see the breakdown details of exactly what was wrong. And we see the types of threats by connection and the types of threats by devices. And again, the fine-grained detail explaining why those were bad. And then we repeat that for more of our zones. So thank you for taking the time to watch this video with me.